Okay, so let's wrap up example problem number 3. So where we ended, we solved for the x and y component of our resultant vector. So if I were to dry that out, because they're both positive, I would say here's my x component. I'm going to add that to my y component. So my overall resultant would be here. And so it's the sum of the forces, not just in the x and y direction, but all together. Okay. And so we have a right triangle. And we know our A and our B, and so we can solve for C using Pythagorean theorem. A squared plus B squared equals C squared. Or C is equal to the square root of A squared plus B squared. Okay? So I can plug that in. Let's see, the sum of the forces in the x direction was 38 newtons. I'm going to add that to the sum of the forces in the y direction, which is 30 newtons. Okay, so we have the square root of 38 squared plus 30 squared. Oops, 48.4, 2 sig figs. Sum of the forces is equal to 48 newtons. Okay, so we have the magnitude, but now we need the direction component. We need to know what theta is here. And so we're going to use the tan inverse, right? So theta will equal tangent inverse of opposite, which is the y for this. Sum of the forces in the y divided by adjacent, which is sum of the forces in the x. Okay. So we're going to have tan inverse, where sum of the forces in the y is 30 divided by sum of the forces in the x, which is 38. Okay, so that will be 38 degrees. There's the magnitude and the direction of our resultant vector. All right, last example for today. So what is the sum of the forces in the x direction and the y direction for the following free body diagram? Then define the resultant vector for the free body diagram. Okay, we need to break up. We have a lot of forces going on here, and we need to break them up into their components. So the force due to gravity is all in the y direction, same as the normal. This force of the motor or thrust, that's all in the x. But then it looks like we have two tensions going on. And this first tension is at 40 degrees. Okay. And then the second one is also at 40 degrees. Okay. We got a lot of 1 sig figs here. Let's change that. Let's put a decimal on these. Let's make that change in our notes there. Let's be working at least with 2. Okay. We need to break up the force due to tensions into their x and y components, okay? Because we have force due to tension 1 in the y as well as the x, and then we have force due to tension 2 in the y as well as the x. Let's do that over here. Force due to tension 1 in the y direction. So that's going to be opposite from the angle. So I'm going to use sine. So I'm going to take my hypotenuse, 55 newtons, sine 40. Okay. And then force of tension 1 in the x, that's adjacent. So that's going to be 55 newtons sine, cosine 40. Okay. So we have 35 newtons, and then we have 42 newtons. Okay, good. Now let's look at force of tension 2 in the y. So that's going to be opposite as well, right? So we'll take our magnitude, which is 30 newtons, and it's going to be multiplied by sine of 40, okay, because it's also 40 degrees. And then force of tension 2 in the x. X is adjacent to that 40 degrees, so that would be 30, because that's our hypotenuse, newtons cosine 40. So 30 times by the sine of 40, that's 19. And then cosine, that's 23. Okay, so we broke these into their x and y components, right? So now let's write out the sum of the forces in the x direction. So in the x direction, we have the force of the motor, and then we also have the force of tension 1 in the x. Okay. Also in the x, we have force of tension 2 in the x, but that's a negative. All right, and let's write those values in. The force of the motor was 40 newtons. The force of tension 1 in the x was 42 newtons. And then force of tension 2 in the x, that was 23 newtons. Okay. So that would be 40 plus 42 minus 23, 59. So 59. The sum of the forces in the x direction are equal to 59 newtons. Okay. Now let's look at the sum of the forces in the y. In the y, we have a positive force normal, and then we also have a positive force due to tension in the y. So force due to tension 1 in the y, and then we have another positive force due to tension 2 in the y, and then we have a negative force due to gravity in the y. Okay, so that's all of our forces or components of forces in the y. Let's add our values. The normal force was 40 newtons. Okay. Our force due to tension 1 in the y was 35 newtons. Okay. And then a 2 in the y was 19 newtons. And then our force due to gravity was 20 newtons. Okay, so 40 plus 35 plus 19 minus 20. So the sum of the forces in the y direction are equal to 74 newtons. Okay, so we know our x and our y component. Let me check where we're at on time. Okay, good. Now, let's look at our resultant. So we have positive x, positive y. The y is larger. So if I were to draw this out, I'd say, okay, there's my x, there's my y, right? This is some of the forces in the x direction, some of the forces in the y direction, and I would have this resultant, or just the sum of the forces in general. Okay, right triangle. So like before, we're going to use Pythagorean theorem. So the sum of the forces is equal to the square root of sum of the forces in the x squared plus sum of the forces in the y squared. Okay, so I'm going to plug that in. So I have the square root of the sum of the forces in the x, which is 59, squared, plus sum of the forces in the y, which is 74 squared. and that gives us 95 newtons. I shouldn't put X there. That's just some of the forces in general, not the X component. Okay, nice. We know the magnitude. Now let's figure out what that angle is. So we're going to do tan inverse. Okay, so tangent inverse of opposite, which would be some of the forces in the Y, divided by some of the forces adjacent in the X. That'll tell us the theta. So tan inverse of Y, which was 74, divided by X, which is 59. And so that will be an angle of 51 degrees. There's the magnitude of the resultant, and then there's the direction of the resultant. Okay, so that wraps up lecture for today. And then next time we're going to look at some static equilibrium problems.